Okay, well, thank you for joining me. Today we're going to cover Athabasca Leismer from a technical perspective. We're going to talk about the D54 presentation. And as mentioned to you guys, we're going to cover a little bit more details on the assignment for this week. And we talked about basically extracting data from AccuMap on the asset perspective, then extracting data from individual pads, understanding parameters like steam injection rates or production rates, steam to air ratios, instantaneous and cumulative, gas injection rate, which is basically the NCG, and really plot the relative performance from SAGD to NCG. And so one of you is working on this project, so this is in benefit of everyone. But last week we talked about MEG, Christina Lake asset. So this week we're talking about Leismer Athabasca asset. So D54 directive. So here they have an overview, development overview, subsurface overview, surface operations, and regulatory and compliance. We're mostly going to be talking about the technical stuff. So this is the Leismer asset, right? You can see we had a video that we've done before where we looked on the map where it is. So it's another one of those Athabasca kind of McMurray regions. And on the map, you can see how it's kind of related to Fort McMurray here. So you have Fort McMurray here on the north and Central Process Facility from kind of the Leismer side here. And then we have the individual pads on the right side right here. So in this area right there. And what you see is happening here basically is that they have the lease area, which is the pink stuff. So the pink stuff is the lease area. The development area is the pink, and the red region is the lease area. Pad drainage area is in black, so it's everything that's currently produces. And the approved drainage area is those kind of blocks. So this is like future development. Like you can see pad 8 here, central pad 8 was already developed, but pad 12 will be developed and pad 10 will be developed. And so like we talked in the past, each one of those pads will have well pairs, so injectors and producers. And it kind of varies from pad to pad how many. So for example, pad 6, at least on this, I can count 1, 2, 3, 4, 5 well pairs. So this will mean it will have like 5 injectors, 5 producers. So this asset is growing to 40,000 barrels a day, and current production in this asset is 26,000 barrels a day. And it has basically capacity now to produce 28,000 barrels per day. And that's again a function of this central process facility, ability to handle the liquids and inject steam. So you can see it has 8 producing pads, 54 horizontal well pairs, and 21 infill wells. Do you guys recall, and maybe type in the private chat, what are the infill wells? Like what is their job? So infill wells, 21 infill wells right here. How is this different from the well pairs? How is that different? So we're talking about this right now. 21 infill wells. So one example of infill well will be maybe like right here in the central kind of the pad. No? So the difference between the infill wells and the well pairs is that between the steam chambers, between the well pair regions, we can introduce infills. Yeah, that's right, Alex. So they're placed in between. And this happens when the chambers merged normally and when the oil is mobilizable, when we can actually move it by gravity. Yeah, exactly. We collect the production between the chambers. Okay. Yeah, excellent job. All right, so approved for development is pad 4. So I don't see it on the map. Where's pad 4? Maybe it's this guy. No, this is pad 9. Pad 11 and 10 are here. and 12 as well here. And where's pad 4? Right there. So pad 4, 4 redrill wells. So they're going to redrill them. See, that's what the oil looks like, bitumen looks like. And when you drain it, the emulsion, it kind of looks more like this, but it partitions and has higher water cut. And so at the central process facility, you basically remove the oil to sales oil from the water, and you reuse the water and basically reuse it to make more steam. So then one of the questions could be, how did they know to drill in this area? Like how did they know to develop those pads here? How did they know to do that? Well, this picture shows you that they have cored wells and image logs wells from this entire region, and they were able to basically decide where to drill for the oil based on the logs. And so these logs will have really good representation of the regional geology. And here you'll have the central process facility. And so now they decided, like 10 years or 15 years ago, they decided to go this way. But now they're kind of going more that way to pad 8, which is a wonderful pad. So this is one of those logs that I'm talking about. So here you have basically the oil and the various oil saturation composition. And you can see kind of the pay level. So the thickness, I guess, from the pay. When we covered MEG, we talked a little bit about that as well. So here you can see it's about let's say 15 meters in vertical depth, and here is like 444. So it's about 30 meters difference. Here you can see a bottom water thickness map. So usually when you have a formation like this injector producer and you have the chamber, here you'll have the overburden, here you can have underburden. So what they're saying here is that in some sections you can have bottom water, right? And basically they map it for you. So notice how they ignore this region, they ignore this region, they ignore that region. And most of the pads where they drill, they don't have bottom water. So pad 8 doesn't really have any bottom water based on kind of this diagram. And the other new redevelopment wells here, 11 and 10, they also don't have much bottom water. So this is top gas thickness map. So top gas is in this region here. And you can see some pockets here of regional gas. Here, here, right? Here a little bit. So you can tell that they also tried avoiding those. So that gas region based, I guess, in the central here, this could be as high as 8 meters pay, 8 meters. But obviously 0 here and maybe like 2 meters here. So why do you don't want to exposure to a lot of gas? So let's say you have injector producer and you have chamber development, and maybe I'll use blue color here. So blue for gas. So now that gas is mobile, right? So just like you learned about the different phases, it's mobile. And so now that the steam is rising upwards, that gas could come into the chamber and now you're forced to produce it. So you really want to mitigate the exposure to those type of heterogeneous zones like bottom water, which you could have here, top gas. So that's why it's really, really useful to have this type of maps so you know exactly like what's where and kind of where you want to develop the resource, right? So obviously in the future you may want to develop this area here, maybe this area here, a little bit here, put some infills, maybe here. Depends on the bitumen kind of content, saturation. But you also want to deal with the bottom water. But the sector developed a lot of methodologies to deal with bottom water. Like for example, the way you maintain bottom hole pressure. There's lots of ways to mitigate top gas zones as well, or avoid them like they do here, or kind of be mindful of your operational strategy around the top gas zones. So just something to keep in mind. Okay, let's address some questions. to improve the continuity between injector and producer. So is that in the context of infill wells? Yeah, so you want to, so yeah, exactly. So you want to, like, if you have a steam chamber here and one steam chamber here, and so that zone, let's say, is now mobile right here. So you'll put like an infill well here, and you can drain that region, right? So in this way, you kind of go that way. So because obviously the way the chambers are shaped makes this kind of teardrop looking thingy like this. Okay, teardrop like this to be drained. So you need to drain the teardrop. So it makes sense, yes. So here, this is the bitumen pay classification. And again, you can see why they landed where they landed, and we can see where they're going to go next as well, right? Like you can clearly see it. Like what will be a logical? I'll paint for you three numbers. One. Okay, let's use a better color. So 1, 2, 3. So in the private chat, tell me, where would you go? Where would you drill next? In 1, region 1, region 3, or region 2? And this is where the CPF is. It's right here, CPF, Central Process Facility. So now you need a pipeline to here, you need a pipeline here, here. But where would you drill first based on the pay classification and what was done historically? Let's see some numbers from you guys. 1, 2, or 3. Where would you go? 2, 2. Okay. So they decided to go to 3, closer to pad L8. And I think maybe because when you see something that kind of darker regions, right? So darker regions, like here, or here, or here, that means you have more of that pay height, which is higher, 40-meter pay height. So if you have injector producer and chamber, that elevation is higher, it's 40 meters, right? So many of you said 2, which was here. So this classifies maybe between 20 to 35 meters, where this region here may be closer to 40 meters. But I think based on this classification, like it's very subjective. So you guys probably right, because if the pay height is the same here as here, you could go to 2 as well. Yeah, especially if you have kind of some wells that are not doing as well in pad 1 and 2. So you will go towards a region 2. But you see in their development area, they decided to go, actually, what they're telling us, they're going to go 11, 10, 12. So they want to stay in this region more, which tells me that the pay height in this case, or gross bitumen in place, GBIP, is more better here, right? So do we have any questions associated with that? But again, I think you guys are right as well, because it kind of becomes subjective because of the coloring, right? So, okay, and think about this oil saturation, I guess, which you can see here in McMurray here, and then we have top gas and all that. So what they're saying here is that they have various classifications. So in our simulations, we're going to use very simplistic kind of mechanistic models. So they will not have all of those geologies integrated necessarily, but most of the geologies for all of the assets you guys are looking at, they will have some kind of classification based on percentage of mud. And the different way of saying that is that they could have like various heterogeneous kind of geology or porosities or permeabilities, and also mud content. So what you can see here is that F1 is classified as breccia, so variable mud. F2 is sand, which is what you want, which is what you see here. So that's 0 to 10%. And this is basically like a very low heterogeneity. So this is like homogeneous reservoirs with sand, very little mud content, so very little basically low permeability kind of regions. It gets more challenging with sandy IHSs. So those are defined as inclined heterolithic stratification. So when we did the MEG presentations, we talked a lot about this. So IHS, we talked a lot about that. You may recall that. And 30 to 70% content is muddy IHS, and over 70% mud content is basically not classified as bitumen in place because it's not really drainable. So just imagine like mud. It's not like a oil sponge like what the oil sand will be. So it's very difficult to drain oil through that. And it also has, as you can see here, lower oil saturation and lower porosity. That therefore you classify porous medium, I guess, and porous oil sand recoverable or gross bitumen in place by saying that it's more than 27% porosity, and whatever is less than 50% oil saturation is challenging to be produced. So do we have any questions based on that? Is that somewhat clear? I'll zoom in for you guys here. See? So right there, right? So that's where they want to be. That's where they choose to be. Okay. This is some historical kind of content and based on seismic, so we're going to ignore that. So what they do here, you can see they take like kind of like a cross section, through the pads, and they show it to us. So this is A here. I think it's A. Let's zoom into that. This cross section will be, yeah, so A is right here, and then the end of that cross section A right there, and the end is B. So then they go kind of like this, and this is the pace that we see. So, and this is for those of you who were asking about the various parameters of the pay zone. So you may recall there was a question about pay and or chamber height. Some of the concerns we had during our discussions today. This is applicable because you can see how we get 28 meters and 29 and 26 and 27. In some sections we get 22, then 27, 34 again. So do you see kind of why it's challenging to kind of make one assumption and then assume that everything works the same way? Because you do have different saturations here, different pay heights. So obviously the production rate in some cases could look like this, but in some cases could look something like this as well, or like this, right? I mean, it depends on pay height, geologies, all kind of configurations. So are we good with that, guys? Okay, so here's obviously the chart that we're all familiar with from Meg Energy. So this is same thing, but for Leismer. So as you can see here, we're gonna do a deeper dive on this. Production history and reporting year highlights. So they 8 producing pads, 54 SAGD well pairs, 21 infills. They get pad 8 middle 5 well pairs converted to production. So that pad 8 that we talked about, it's right there. That pad 8 right here. So they providing an operational update on that. And pad 7 infills began, and pad 4 well pairs producers shut in Q4 2023 for re-drill operations. So re-drill basically, let's say this is injector producer and you get like this, and now they need to re-drill a well. So then imagine like it goes kind of like this way. So now they re-drill it. So now the producer could be here, adjacent to the previous producer. And now maybe they can collect that pay, or I don't know, or maybe they can redrill it a little bit further away. But in the horizontal plane, which is this one, you will not see the difference. It will be kind of like going like this, like a redrill, right? This could happen for various reasons, but obviously maybe they want to improve operations or they want to recover more resource. It could be kind of like almost like an infill well benefit in a sense. Okay, so let's kind of spend a little bit time analyzing this graph here. So what we see here, just like in the MEG energy example, we always have steam injection. So steam injection, what color is that always, guys? Steam injection. Let's see, it's a very easy answer. Steam injection is always in red. Great. What about oil? Oil injection is always in green. Excellent. Green is the answer. What about, yeah, everything else is kind of, there's no real convention. But I guess what I've been seeing is that NCG or gas injection been kind of orangey yellow. I guess that's the case here. And in both cases, we've seen CSOR, ISOR kind of in black, right? So, but yeah, thanks for the answers. Really good. So again, what do we see here? We see steam injection rate, and that goes to about 10,000 cubes. So this will be what, like 63,000 barrels a day, right? So if you think about this, and so 10,000 cubes, right, times 6.29, you get in barrels. And if your SOR here is what, like closer to 3, so then oil production rate should be 20 something, agree? So then when we look at the green line, this is the green line, we're at about 2,000 cubes. So that will be what, just over 12,000 barrels a day, 13,000 barrels a day. And here we go a little bit higher towards 3. So let me use a calculator here. So if we get 3,000 barrels a day, then 3 times 6.29, we get 18,000 barrels a day right here. So 18,000 barrels a day right here. And then we go down and then we increase. And so this asset right now actually was able to increase production to 26,000 barrels a day. So I think at their peak, they were like something like 22,000. So now they're at 26,000. They can produce 28,000, but they're going to 40,000. So with all those pets that are integrating, they could go to 40,000 barrels a day. And obviously, what happened in the orange line, based on our project here, that what we're focusing on to keep things in the context, what happened in the orange line? Can we get somebody to kind of quickly write something? What do they see that took place here, and why maybe that happened? So we're talking about this orange line right here. So what happened here? Development of new wells. Well, development of new wells, you will see a well count. So well count is in brown, right? So let's use brown here. So brown, we see increase in well count. So yeah, that's a good answer, right? But look at the steam decline. Steam decline took place, but well count increased. So what then happened? How is it possible that you increase the well count, but which is, I guess we have some answers here, because we have 54 SAGD well pairs and we have 21 infill. So now we have what, like 75 producers? Is that right? 75 producers. So if you increase the well count, which is kind of where we're at right now, so 70, 75, what happened with the orange line? Huge fluctuation in fluid rates, yeah. Well, the orange line is gas production rate, but how is this related to what we've been doing? Is that you would notice the purple line, and the purple line tells us a really cool story of NCG co-injection. So then towards 2020, there is huge uplift in injection rate for NCG co-injection in the purple line. You guys see it? And the orange line is the gas production rate, that's been taking place. But then obviously it really increased, especially during the time of NCG co-injection. Do you guys see that? So it correlates with the NCG co-injection. So you inject basically more methane, and you produce more methane back because you injected more by definition, right? And notice they actually did a good job cutting energy intensity inputted into the system, because as you can see here, steam injection declined. And then it increased, but then we're also utilizing more water, more well pairs, more wells, right? So that's good. That's efficient operation, right? So let's see what we covered so far. So we covered so far oil rates. So we talked about oil rates, so we see them. Gas production rates in this orange line. Water rate, which is I guess water production rate in the blue, which correlates with what? What does water production rate correlates with? So this thing. What does that correlate with in this chart? What's the source of that water? Steam, exactly. Good job. Good job, guys. So you injected steam, the steam transferred the heat, and then it condensed. So now you produce it back, right? So we covered that. Well count, we talked about this. So this is this number. Steam injection rate, which is in red. Gas injection rate, which is the purple stuff. CSOR, which is this kind of line here, and instantaneous SOR, which fluctuates. You see, and last time we talked about why we have ISOR and why we have CSOR, and you can clearly see that instantaneous SOR is busier, much busier, but cumulative SOR gives us an overall direction of where things are going. So you can see here the CSOR was increasing, but now it's kind of declining. And NCG co-injection, so NCG co-injection helps with that CSOR declining. Now, you could say, well, maybe it doesn't decline that much, but it does relatively to oil uplift, which is here, because before you produce less oil and now you're producing much more oil. Do you guys see that? I guess this is not about like selective biases or kind of having some kind of agenda here. It's really speaking to the charts of what's been shared in D54 public domain and analyzing through like a technical expertise to better understand the performance on this asset and what was done and what was achieved, and make this study of SAGD versus NCG co-injection. So that's our goal, guys. Do you see that? Do you see the benefit here? Excellent. Okay, so now we have some reservoir properties here as well, and that's kind of where I'm gonna stop this. Maybe we'll talk a little bit more about NCG here, and then we're gonna stop. So just like we did with MEG, you have a table here where you have the various pads, and then you have the inputs, right? So we talked about infills, So they tell us exactly where they put the infills. For example, pad 7 will have 4 infills. Lateral length. So some of you expressed uncertainty, like how long are those wells? Where, well, it clearly stays here. So states here. Pad 6, for example, will have 860 meters of lateral length, but pad 8 will have 1250. Now, pad 8 is a little bit of a later pad. So what do you guys think this company is doing? Are they drilling shorter wells or are they drilling longer wells? Considering well 8, pad 8 is a new pad. So what do you guys think? The drilling shorter, longer, right? Why do you think they drill longer wells? So why do you think they drill longer wells now? Proof success. Maybe they want to recover more resource, right? Maybe they want to do more with less. So they want to drill the one time and get more oil uplift. So, right? So, but it clearly shows here that before they would drill 745, 695, 900, and now they're drilling 1250. So, oil saturation, you see it's pretty good. So, about 81%. Porosity, pretty good, about 34%. Do you guys see on now we're looking at permeabilities. Do you see why they went to pad 8 versus staying closer to previous pads? Look at the permeability here, 6.2, and right here, 4.9. This is the highest, right? Do you see why they went there? So the pay thickness is also pretty good. So 25, 29, 22. So similar to in the past. But for example, this one had 35. And that's why they want to stay closer on that bed. And that's why they drill the infill well. See? That's why they did the 4 infill wells, because they want to take advantage of the 35-meter pay thickness. But they're really taking advantage of pad 8 because it has really nice permeability. Do you guys see that? And by the way, if you're not sure about what's new, what's old, all you have to do is look at the recovery factor and say, hey, mid pad 8 only recovered 4% of the production, but pad 4 recovered 48%, and pad 3 recovered 57%, and north of pad 8 recovered only 17%. So you can see basically what aged and what's newer and what's older. And obviously we have this ultimate recovery factor, right? Estimated ultimate recovery factor at 55, 65, 65, 75. So we have a long time to go here on pad 8, which is a fresh new pad. But we also have lots of time to go on other pads as well, right? Like if we've been going for 10, 12 years now on the other pads, maybe like, well, I think it's about 7, maybe 8 years, something like that. And you recover that much, well, to achieve 65%, you still have more time. You still have 1, 2, 3 years, right? So you're kind of in a good shape here. You guys agree, or what do you guys think? Any thoughts, any questions before we move to our final slide? Yeah, I really love your support, Raylene and Alex. Like you guys are amazing because you always give me feedback, keeping me in the loop, engaging with me. I really appreciate that. Thank you, guys. Thank you, John. Because it's kind of weird talking to yourself if you think about it. You just sit here and talk to yourself, right? All right, so let's look at NCG co-injection now. So, okay, let's read this and then we're done, and then you can go. So NCG co-injection started in 2019 for SOR optimization. SOR optimization. Pads 1 and 4 NCG co-injection used for SOR management continue to see improved SOR on these pads. So now, for the people that work on Leismer Athabasca asset, you know what data you're going to extract in AccuMap to analyze NCG co-injection benefits. And the answer is right here. Are you happy about that? Yeah, exactly. So no observed negative impact of gas co-injection to recovery factor outlook and wellbore integrity, so that's good. NCG implemented to pads 5 and 6 starting May 2021. Will evaluate implementing NCG co-injection in pad 7 and constrained NCG co-injection rates in winter months due to MDMT limitations. MDMT limitations. I don't know what it stands for. MDMT. Maybe management something, downhole management, temperature, right? Let's think about it. Management, downhole. Anyway, you get the idea, right? So in the winter, they're basically constraining NCG co-injection. Maybe they need more enthalpy as they co-inject the stuff. So let's look some representative pad performance. So now we have rate here. We have steam rate. We have steam rate here and oil rate here. We have oil and steam rates here and right here. And NCG injection rate and SOR. So like this. And pad 5 and 6 NCG rate and SOR. So now let's observe. They inject NCG, SOR goes down, right? So they inject NCG, SOR plateaus here. See, they tried a couple of different things. So now our job is to go to previous years before this happened. So right here, in this point right here, and understand what happened there prior to that, to see what was that ISOR and obviously we didn't have NCG, but you can tell even from here, like if I clear all this, you can take just based on this right here and right here, let's take average. The previous SOR was 4.5 and now SOR 3. So then you go 3 minus 4.5 divided by 4.5, and now you get the benefit for pad 1 to 4, NCG injection rate, and SOR benefit. Now, before I conclude, one thing I wanted to tell you, minimum design metal temperature. Yeah, could be. Yeah. Thank you. Yeah, just to avoid kind of like cooling shocks, right? In thermal shocks, right? Yeah, thank you. Minimal design metal temperature, yeah. It's been a while since I've seen this term, and it's been a while since I talked about cooling shocks, but maybe that's what they want to avoid, right? So they don't want things to get too cooler by reducing the enthalpy from the injected stream to avoid cooling of the metals. So thank you for that. Okay, so now just to conclude, you guys are working, let's say, on Leismer to understand NCG to SAGD benefit, and now they're talking about pad 1 to 4, and let's take a look, because this is the challenge many of you are going to have. What you're going to see here in this map here is that many of those chambers here, so this is pad 1 to 4, so let's zoom into that. And by the way, this is very relevant to all of you, so highly encourage for everyone to listen. So notice this, pad 1, 2, 3, 4. They treat them as one system. Why is that? Why are they looking at all this, NCG co-injection, and they evaluate all of those things? I'll give you a hint. Why is that? Let's see some answers. Same configuration, yes, but the answer is really, is all of those steam chambers, they now coalesced and everything is communicating to everything. And so when you inject non-condensable gas, it's non-condensing, it's gas, and gas moves, right, by pressure gradients. And so what they did, they didn't look at one pad they look at the system of the pads. So the overall, so they consider this entire thing as ocean. Yeah, exactly. So steam chambers overlapping, and another word for that will be steam chamber coalescence. So they all coalesce, and so what they look at the overall system. So in this specific case, whoever is watching under Leismer, for Leismer, you can extract information associated with pad 7 maybe independently because it doesn't coalesce with anything. But when you look at pad 1, 2, 3, 4, you may want to extract all of them and aggregate together and to look at this as one system. So when you make your selection in AccuMap, select 1, 2, 3, 4, all of those pads. Or you may choose to look at all of this region as one system to understand the NCG benefit, because maybe some of that gas migrated to pad 7. And then obviously we don't have communication with pad 5, and we don't have communication with this region here. So it's up to you. You decide what you want to do here. And then when you specify your assumptions, you just say, I assumed the coalescence between those chambers. I extracted data for this, and this based on my assumption, but it needs to be logical. Does it make sense? Okay, my friends. Any questions? Okay, so we're done for now. We talked about next week. So start extracting data in AccuMap for your individual assets and the pads. Also kind of start aggregating data in one report. And maybe for those of you that need to maybe add some language, discuss some of those parameters for your assets, please do so. And yeah, so this week we're going to focus on aggregating the well, not aggregating, but combining some of the write-ups and looking at AccuMap. And I want to do in person for sure. Let's kind of like, what works best for everyone? What time works best? Wednesday, Thursday? Anyway, send me an email, talk between yourselves, and kind of give me a proposed couple of dates, couple of options, and then I'll see you guys next week for that. So we can sit and kind of go over some of those files. But spend time this week extracting some AccuMap data. Again, don't get stressed over it. Just kind of make assumptions. Say, I assume pad 3, 4, 2, 1 coalesced. Maybe for other individual assets, like some of you looking at Jackfish, some of you looking at Firebag, Sunrise. The pad that you pick, maybe it's kind of maybe it's standalone pad, maybe it's kind of a cluster of pads. So communicate your assumptions as well, okay?